Hello everyone. So the next topic in our bucket is segregate even and odd nodes in a linked list. So the problem statement is given in a way such that this will be the input linked list. Okay. Now you can see the green color are the even numbers, even data. Okay. So some even data is over here, some in between, at the end. And similarly the blue data is the odd data in the start, between, in the end. Okay. Now, what the question wants us to do is that we have to modify the linked list in a way such that all the odd data come in the right side together and all the even data come in the front side, in the start side together. But we have to maintain the order. That is, if 8 is over here, then it will always come in the first because it was the first even data. Now, if 4 is over here, so it has to come as the fourth place only. It cannot come over here. Okay, we have to maintain the order. So it's very simple. Come, let's come to the code. Code for this. Okay. Segregate even and odd nodes in a linked list. Okay. So as I mentioned in the previous video, we have to do the problem from scratch. हम scratch से करना है. तो हमें ये inner class, we have to create this inner class. Okay. With the features next and data. You can also put val also over here. Okay. But I prefer to use data. More familiar with it. ठीक है. तो सबसे पहले इस helper function complete करते हैं. As the name suggests, segregate even odd node. So what we'll be doing simply is that the head is given. That is, we have been given this as the input. We have been given 17, and 17 points to all of the nodes. Okay, so head is 17 over here. And what we have to do, we have to declare some pointers. Suppose हम ऐसा करेंगे. Node even start is equal to null. Okay, odd start equal to null. Then even end equal to null and odd end equal to null. We have declared 4 pointers. Okay, and one more pointer, that is node 10 is equal to head reference variable. Now initially the even linked list has nothing, odd linked list has nothing. So the start and end points to null over. Now what we do, we say while 10 not equal to null. So what we are doing over here, यहाँ क्या कर रहे हैं? Traversing the linked list. Okay. अब हम क्या करेंगे? We say node current equal to 10 and node value is equal to current dot data. Okay, here sorry, it will be int value. Now we'll say if value mod of 2 equal to 0, that is even value, then now what we say, we say if even start equal to 9, that means the even linked list was empty. Then what we have to do? We have to say even start equal to current and even end is also equal to current. Okay. Hence what we have to do is say even end dot next equal to current and even end equal to even end dot next. So if the even link was empty, so we'll assign the even start and even end to current. But if it was not empty, it has some 1, 2, 3 nodes. So what we'll say, we add all the nodes coming next from the end side. So we say even end dot next equal to current, and then we have to update the even end. Now the even end is the current, and current is on the next side, so we have to say even end to move one more step ahead. Okay, This is the scenario of given case. Now else, that means for odd value. So for odd value, we'll do the same thing. So I'll slightly copy. So this is for your reference to remember the code simpler, easier. So what we'll do, we'll say odd start equal to null. So we'll just say odd start and then we'll say odd end. Okay. Otherwise we'll say odd end dot next equal to current and odd end equal to odd end dot next. Okay. And coming out of the if else block, we'll say temp equal to temp dot next. We'll keep moving one step at a time. Okay. Good to go. अब क्या होगा even और end, even और odd linked list बन चुकी है. ठीक है. Now we'll come out of the while loop, end of while. अब ऐसा भी हो सकता है, there can be a scenario that we have been given an input, it will only have odd data, it only has even data. So one of the linked list will be empty even or even linked list or linked list. We have to check. Now after coming out also, if even start equal to null, that means no even value was found. Okay. So what we say return order, sorry, or start. And if that is not the scenario, let's say if odd start was equal to null, no odd value was found, क्या करेंगे? फिर से रिटर्न इवन स्टार्ट. ठीक. अब अगर ऐसा सिनेरियो नहीं हुआ, कुछ कुछ इवन लिंक लिस्ट भी है, कुछ कुछ और लिंक लिस्ट भी है. इफ कोट एलएल सिस इवन प्लस और, अब हमें क्या करना है? द इनपुट was given and the output wanted the events to come in the first side, the front side. So what we'll do, हम ऐसा करेंगे कि we'll now say that the odd end should point, odd end dot next should point to null. Okay. and जो even end है उसका next point करे odd start को. Perfect. And जब ऐसा हो जाए, then it is done, then we can say return even start and the question is complete. Okay. Okay. I hope it's clear. So this is the portion. Then you have to just change even to odd, and then you can create this portion. Checking the value, current variable, value variable. Okay. Until temp not equal to null. So we're moving temp from one step at a time. When coming out of the while loop, we'll check if one of the linked list is empty. So we'll return another one. And one more thing, one more thing. Don't miss over here. Suppose there's a case that head equal to null. Okay. Or 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 they can be scenario that head dot next equal to null. That's it. Either the linked list given as input was only empty or it has only one node. So in that case, we don't have to work out anything. To reduce the time complexity, we have to write this statement at the very start and directly return head over here. No need to create even start or start and perform such things. It ऐसा करने से टाइम ज़्यादा लगेगा. It will take a lot of time. तो अब ये function complete है and correct है. Okay, it's correct. Now this function says print list. So we'll complete this. What we have to do over here, we have to write the code that will print the values of linked list. तो तरीका क्या रहता है? What is the method? We'll take a temporary node over here and assign head to it because we don't have to displace any of the inputs. Okay, we have to we want the head pointing to the initial head only, so we are using a temporary variable over here. So temporary node. अब क्या करेंगे? We'll put a while and we'll say temp not equal to none. Okay, so we are at the first place. Supposingly I say int value is equal to temp dot data. Okay, now I say print value. I want the expression to be in this format. Okay, and suppose I say temp dot next not equal to none because at the last node it should not point to anything. Okay, or we can do away with this also. So at the end we'll say point to none. Okay, so this is the small code snippet to print the interest. And again, जैसा मैंने पीछे बताया था पुराने वीडियो में, previous video में, in the first one. So the scenario could be like you have to complete only these two functions. Okay, this can be inbuilt and given in this format, coming to format. But in our scenario, we would be asked to write line by line from line number 6 to the last line. Okay, we have to create the main method also, and in the main method, we have to take input from the user. Okay, so how we'll do that? We'll create a simple object of scanner class, say SC, and then first we'll ask the size of the linked list. Size of linked list. How many elements? Okay, so we'll ask this, and if the size is say 0 or negative, that means the linked list was empty. So we can simply say over here empty linked list. Okay. Otherwise, what we'll do, we'll take two pointers, head and tail. Head will point to the leftmost node and tail will point to the rightmost node. Like the first node on the from the left side is the head, and the first node from the right hand side is called the tail. So initially it will be none. Then we'll create a for loop over here. We'll ask values from the user each and every time. We'll create a new node. In case head was null, that means the list was empty. So we'll say head and tail to be equal to that point only. Now the linked list has only one node, and that is called the head and tail as well. Suppose if the linked list has some nodes, so what we'll do is else block, and on the right hand side, on the end side, tail side, we'll keep adding the new nodes. Okay, so tail dot next equal to new node, and then when this has been done, the tail has to be moved ahead. So we have to update it, and now the tail is equal to the new node itself. Okay, now at the end, because the segregate given node function returns a node, so in the head variable itself, okay, or we can write over here node answer. Okay, node answer, and we can send answer over here. Okay, now let's see how it works. So we can take the same input. How many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes are there. First we'll enter 10, then we'll enter the values 17, 15, 8, 12, 10, 5, 4, 1, 7, 6. Okay, okay, there has been a mishap. Ah, so I found the fault over here. That is, over here we are not updating the temp. That's why it's going in invalid loop. And we have to say temp equal to temp dot next. Okay. Otherwise it will not come out of the while loop and then it will keep on moving in loop infinitely. So don't make such mistakes. But this is the way you can deal with it. Let's try once again. Size is 10, 17, 15, 8, 12, 10, 5, 4, 1, 7, 6. and the output as it is. You can compare with it. It says first is 8, next is 12, then 10, 4, 6, 17, 15, 5, 1, 7, and then none. So all the elements, even elements from 8, 10, 4, 6 are in the left hand side, front side, and all the odd elements are on the right hand side. So that's all for today. Thank you.